Hello everyone. So today we will be doing the very important topic of the day, and it will be like empirical formula and the molecular formula and how to relate these two things. So let's begin that stuff. Chalo, come over here. So I'm beginning with that. So we'll be doing, like, say if I give you some molecules like say C6 H12O6. C6H12O6, and we have got C5H10O5, and we are having like say C2H4O2. So these are some molecules, and these are the molecular formula of certain molecules. Okay, but I mean these are not the simplest one. If I divide this by 6, say I'll get what? CH2O. Okay, if I divide this by say 5, I'll get CH2O, and if I divide this by say 2, I'll get what? I'll get CH2O. So these are called empirical formulas. So if I ask you what is an empirical formula, empirical formula are the most simplest ratio of the atoms present in a given molecular compound. You can see that it is 1:2:1, 1:2:1, 1:2:1, and now this cannot be simplified further. Okay, but I mean a molecular formula can be simplified. So can I say that different molecules will have definitely different molecular formulas, but they might have the same empirical formula. Okay, they will depend on the common entities present over there. So can I say that over here that molecular formula will be equal to empirical formula into some common number, so that if I want from this empirical formula molecular formula, I should be multiplying the empirical formula with what? A number, an integer. Similarly, can I say that every molecular formula will have a molecular weight, and every empirical formula will also have an empirical weight? So can I multiply this by n as well? Okay, so remember these two formulas, and we'll be using them in the coming lecture. Okay, so let's try some questions. Can we try some questions? Chalo, come over here. Come. So the kind of questions you will be getting in this part of the chapter will be something like that. Say if I give you there is a hydrocarbon CXHY, a hydrocarbon CXHY is there, and it contains like say 80% carbon by weight, 80% carbon by weight. Now whenever they give you percentage always begin on 100, always begin on 100. So can I say that the total weight of the compound is say 100 gram? They are giving you weight, so I'll be doing weight in terms of gram. Okay, so let the total weight of the compound is 100 gram. Out of that 80 gram will be carbon. Out of that 80% will be carbon. This is say hydrogen. If I take weight, this weight will be what? 80 grams, and this will be remaining how much? 20 grams. So this is the weight of the carbon in this compound and weight of hydrogen in the same compound. Okay, तो अब क्या करेंगे हम लोग? Now what we will do, since weight is the most useless thing in the world of physical chemistry, I should divide the weight by the atomic weight to get number of moles. So find number of moles, that is weight upon atomic weight of carbon, weight upon atomic weight of hydrogen, and this I'll get will be like say 6.6, and this will be 20. Now since I need the simplest possible ratio, since I want the simplest possible ratio, what I should do? I should divide both these number of moles by the smallest possible number over there. So this is the smallest one. So can I say that number of moles will be like say ratio 6.6 upon 6.6 upon 20 upon 6.6. Can I make it 1, and can I make it approximately 3? Try to get the approximate whole number. So this will be containing 1 carbon and 3 hydrogen. So 1 carbon and 3 hydrogen will give you what? Simplest possible ratio. So the empirical formula of this compound will be CH3. Yes or no? 1 carbon and 3 hydrogen. And what will be empirical weight? That will be what? The weight of this formula. How much? 12 for carbon and 3 for hydrogen. Total becomes 15. Yes or no? If I take in terms of gram, it will be like say 15 gram. Now, if the question is there that if the molecular weight of the compound hydrocarbon is 30, find molecular formula. Find molecular formula. Can you find it out? Yes, we can definitely find out, since I have given you a formula that molecular formula or molecular weight will be equal to empirical weight into a number. So N will be molecular weight upon empirical weight, which will be how much? It will be 30 upon 15. 30 is the molecular weight and 15 is the empirical weight. So this will be 2. So N is 2. So if they ask you what is the molecular formula? So molecular formula is also what? It is empirical formula into the same number you have got right now. Okay. So that I believe will be like say empirical formula is how much? CH3. Now into 2, this number, it will be C2H6. So we're talking about actually ethane. Is that clear? So I hope that we can handle this question. Similarly, we'll do some more questions. Chalo, aa jao. Ek aur question karo. Let's say I'm giving you a hydrocarbon CXHY. CXHY contains 75% of carbon by weight. So can you find out the empirical formula? Let's try that. So whenever they give you percentage, always begin with 100. That means total weight of the compound will be 100. So once you begin with 100, the reason for taking 100 is that percentage is done on 100. So once you take the total weight as 100, bachcho, now the mathematics will become very simple. Okay. Now see, over here carbon and hydrogen will be there. तो अब इसमें क्या करेंगे? The weight of carbon कितना दिया हुआ है? Weight of carbon is given as 75 gram and rest will be 25 gram. What? Hydrogen. Since weight is the most useless thing in the world of physical chemistry, I'll go with what? Number of moles. And number of moles will be how much? Weight upon atomic weight, that is 12. Weight upon atomic weight of hydrogen, that is 1. Yes or no? Now go. निकालो उसको. This will be N. कितना आएगा? It will be 6.25 and it will be 25. Now when you get number of moles, you should find the simplest possible ratio, whole number ratio. So divide by the smallest one. Which one is? 6.25. So when you divide that, you'll get 6.25 divided by 6.25 and this will be 25 upon 6.25. This will cancel up and this will be 4. So it is the simplest possible ratio now. What? 1 carbon and 4 hydrogen. 1 carbon and 4 hydrogen. Yes or no? So empirical formula, simplest possible will be CH4. Yes or no? And empirical weight will be how much? Empirical weight will be 12 plus 4. That will be 16. Yes or no? Will you agree with me or not? So can we find out if they give you any molecular weight, can you find it out? Yes or no? Chalo, let me do. So the second question they're asking you, find the possible molecular formula. First I'm giving you CH4, second C2H8, third C3H9 and fourth all of these. चलो बताओ क्या लग रहा है आप लोगों को? भाई, a normal student will say all of these, and the reason being, sir, you right now told us that if you have a empirical formula, to find the molecular formula, you have to multiply empirical formula by a number, integer or a whole number. Then if this is CH4, if I multiply by 1, I'll get CH4. If I multiply by 2, I'll get C2H8. And if I multiply this CH4 by 3, I'll get C3H9. Sorry, CH4 again, CH4. Okay, C3H12. I'll make it my mistake, C3H12. Yes or no? But the correct answer is only this one. And the reason being, this is CH4. CH4 into 3 will be C3H12 है ना. The correct answer is CH4. The reason is that these two do not exist. If they will exist, the carbon valency will be 5 and the carbon valency cannot be more than 4. So only possible formula is CH4. So please don't stop at mathematics. आप chemistry का paper दे रहे हैं, finish it with chemistry. Put chemistry first. Mathematics should come as a support. It cannot be the substitute for chemistry. तो पहले chemistry देखो कि यार ये तो exist भी नहीं करेंगे. These two simply cannot exist, है ना? They are breaching the valency of carbon. Okay? अच्छा क्वेश्चन था ना? Simple but good question. चलो आ जाओ. चलो let's do more questions. Like I'm going to do a different category of question. Just make sure that you are finding it out, है ना? Properly. आओ जाओ. करते हैं इसको. Okay. Can I say that where one more hydrocarbon and let me try that out. That percentage by weight of carbon is given as, what can I give it to you? Can I make it 96%, 96% or say 93.75%, 96% carbon है ना by weight, 96% carbon by weight. So can I move ahead over there? चलो आ जाओ. Carbon and hydrogen. So weight of carbon will be what? 96 gram and remaining will be 4 gram. Yes or no? And weight is the most useless thing in the world of physical chemistry. Can I go for the number of moles? Go for number of moles. 96 divided by 12. Weight upon atomic weight. And 4 upon the atomic weight of hydrogen. Now N will be how much? It will be 12, 8. And this will be what? This will be 4. Yes or no? Okay, now what I should do, this one is smaller. So can I make sure that this will be like, say, divided by the smallest one. It will be 8 by 4 and 4 by 4. So what I'm getting? I'm getting N, not exactly N, the ratio I'm getting. It will be 2 and this will be 1. So carbon 2 and hydrogen 1. So the empirical formula will be C2H. Are you getting or not? Okay, chalo, let's move ahead. So you have to do these questions in a similar fashion. Our next question karte hain. So they are saying that, now see, this question is also a different variety of question, and learn to handle that. A compound, it says a compound contains equal weight of sulfur and oxygen. It contains equal weight of sulfur and oxygen. You have to find out the empirical formula. Find out the empirical formula of the compound. देखो बच्चों, जब भी कभी आपको दो फ्रीडम दें, it contains equal weight of anything. In this case, sulfur and oxygen. What you should do? I mean, you can take any weight. Like many people take, sir, I'm taking weight of sulfur and oxygen as say 50-50. Or they can take, say, I want to take 100-100. You can take any weight. You will get the same answer. But my recommendation will be that whenever you get liberty, that you can take any equal weight of the given two atoms, always take that weight as LCM of their atomic weight. So sulfur is what? 32. Oxygen is what? 16. So the LCM of 32 and 16 will be 32. So my recommendation will be take the equal weight as the LCM of their atomic weight. That way your mathematics will simply evaporate. मैथ्स खत्म हो जाएगा एकदम से ना. तो आपको डर भी लगता है मैथमेटिक्स से, तो मैथ्स खत्म. ठीक है, चलो ट्राई करते हैं इस क्वेश्चन को. दे आर सेइंग इक्वल वेट ऑफ सल्फर एंड ऑक्सीजन. अ कंपाउंड कंटेन्स इक्वल वेट ऑफ सल्फर एंड ऑक्सीजन. सो द वेट आई विल टेक, यू कैन टेक एनी वेट, boys and girls, but you will get the same answer, है ना. But my thing is that I want to simplify the calculations, है ना. 3 घंटे में सारा काम करना है, कैसे करेंगे यार, है ना. I'll take 32 gram and this also has 32 gram. It's the LCM of their atomic weight. Now weight is the most useless thing in the world of physical chemistry. I'll make it what? Number of moles. कितना आएगा? 32 upon atomic weight of sulfur. 32 and atomic weight being 16. है ना. तो काटो इसको. Number of moles will be like 1 and this will be 2. Yes or no? ऐसे काटो, उसे काटो, सब काट डालो. चलो आ जाओ. तो 1 sulfur and 2. I believe this is the simplest possible ratio. There is no need to divide by anything else. है ना. I told you already that this way your maths will become very simple. So 1 sulfur and 2 oxygen. The empirical formula will be SO2. Yes or no? Are you getting it? Yes or no? चलो एक और ट्राई करते हैं. Let's try one more question. A compound contains equal weight equal weight of A and B, and they are giving you atomic weight. Atomic weight of A is given as 10 and atomic weight of B is given as say 20. Can you find out the empirical formula? Same thing. What will be the LCM of 10 and 20? It will be 20 only. So the weight I'll take will be 20. You can take any, but this way the calculations will become extremely simple. 20 and 20. Now to find number of moles, because weight is the most useless thing in the world of physical chemistry, I'll find number of moles. 20 upon atomic weight. What is that? 10. 20 upon 20. This way this will be like say 2 and it will be 1. And this time A 2 and B will be 1. So empirical formula will be A2B1. A2B1 or simply A2B. Is that clear or not? चलो एक और करते हैं. One more question. देखो, so जब भी कभी आपको लगे कि सर कॉन्फिडेंस नहीं आ रहा है, बस एक काम करो, उसी तरह के आप 4 5 6 सवाल लगा दो, कॉन्फिडेंस अपने आप आ जाएगा. सारा गेम प्रैक्टिस का है ना और कॉन्फिडेंस का है. कॉन्फिडेंस रहेगा ना, उठा के फेंक दोगे पेपर को आप लोग. चलो आ जाओ. Again, a compound contains equal weight of A and B. Remember that here I am giving you what? Equal weight. Equal weight. 50% A, 50% weight of B. है ना? And atomic weight of A is given as this time 20 and atomic weight of B is given as 30. So what will be the empirical formula? So the LCM of their atomic weight will be 60, है ना? So I'll take weight as what? I'll take weight as 60 gram and 60 gram. They both are equal. I have a choice, and my choice will be take the equal weight as what? LCM of their atomic weight. Now weight is the most useless thing in the world of physical chemistry. Number of moles will be 60 upon 20, 60 upon 30. This will be 3 and this will be 2. So number of moles will be like what? 3 and 2. I believe this is the most simplest thing possible. We cannot simplify that. So this will be A3 and B2. A3 and B2. Achha, can I share you even more shortcut method? You want that? Even the shortcut, I mean like most simplest thing. So I'll tell you what, like whenever they give you the equal weight of sulfur and oxygen, do one thing, sulfur, oxygen. Atomic weight will be like say what? 32 and 16. Okay. Now when this is only applicable when they have equal weights, when the weight is given equal, only then this method is applicable. Now rather than going into details or cancelling this stuff, do one thing over here. Simplify this only. This will be 1 and it will be 2 times. And then cross multiply, and then cross multiply. I'll get what? SO2. That will be the empirical formula. Chalo aa jao. Let's try this thing over here. So what is that? We have got A and B, 10 and 20. Simplify that. This will be 1, this will be 2, and then cross multiply. A2B1. Yes or no? A2B1. You can finish it off here only. A2B1. Come on, one more question. This time, this is A and B. 20 and 30. Simplify that. Divide by 10 and then cross multiply. It will be A3B2. Yes or no? Same answer is coming. There is no need to go for that also. So whenever that equal weight part is given, you can simply write down their atomic weights just below the element, simplify them and then cross multiply. Just like that. Okay? चलो आ जाओ, एक और क्वेश्चन करते हैं. Let's try one more question. This time they are giving you a compound containing phosphorus and sulfur. I'm saying PSX and SY, and the weight is given as 2.20 gram. 2.20 gram, and they're saying out of this phosphorus, the weight of phosphorus is given as 1.24 gram, and they're saying rest is sulfur. So sulfur will be how much? The total weight of the compound minus weight of the phosphorus. So 2.20 minus 1.24 will be 0.94 gram. So this is the weight of sulfur. Now weight is the most useless thing. I will do what? I'll find out number of moles. And how I'll find out number of moles? Weight divided by the atomic weight. Atomic weight of phosphorus is 31. 0.94 divided by atomic weight of sulfur, that is 32. Yes or no? Since we will be taking ratio, so boys and girls, tell you one thing, that 0.01 upon 0.02, can I write down this as 1 upon 2? Can I write down? The reason being, I have multiplied both of them by 100. On multiplying both of them by 100, nothing will change. The ratio remains same. It will be a 1 by 2 and 1 by 2 only. So whenever we have to take a ratio, I mean, I will like to choose the simplest possible numbers, है ना? So can I multiply both places by 100? अरे इतना मैथमेटिक्स कौन करेगा बच्चों? And I hate decimals. So can I multiply both of them by 100? Nothing will change. अरे रेशियो रिमेन सेम ना, रेशियो विल रिमेन सेम. हटाओ इसको, हटाओ इसको. नाउ 31 into 4 and 32, so this is 96 बच्चे, this will be 96, my mistake, it will be 96, है ना, 0.96. This will be 3, so this will be having like say phosphorus 4 and sulfur 3, it will be P4S3, the empirical formula, and it is the simplest one. We simply cannot simplify that stuff now. Getting it or not? Chalo aa jao. Let's do more questions. Let's do more questions. Okay, this question is good question. It says that a metal forms two oxides, and each containing 50% and 40% metal by weight respectively, है ना? If the molecular formula of first oxide, is MO2, then you have to find molecular formula of second oxide. कैसे करोगे इसको? The question appears little bit lengthy, but it is actually simple, है ना? And many people find it very difficult to handle that. तो करना क्या है? A metal forms two oxides, no problem. Each containing 50% and 40% metal by weight, respectively. That means in the first oxide, metal is 50% and oxygen is also 50%. In the second oxide, metal is 40% and oxygen is what? 60%. Yes or no? Okay, so if the molecular formula of the first oxide is MO2, find out the molecular formula of the second oxide. आ जाओ करते हैं इसको. I'll share the same technique I have shared with you. Beta, utilize the data of the first oxide to find out the atomic weight of metal. Once you find out the atomic weight of metal, you can utilize the data into what? The second oxide. तो करना क्या है बच्चों? पहला जो डेटा दिया हुआ है, पहली ऑक्साइड का जो डेटा दिया हुआ है ना, उसको यूज करके मेटल का एटॉमिक वेट निकालो. एक बार मेटल का एटॉमिक वेट आ गया, उसको यूज करना है कहां पर? सेकंड ऑक्साइड के अंदर. ठीक है, चलो कैसे करते हैं? आई विल शो यू द एग्जांपल. सो लाइक से आई एम हैविंग metal oxide, like say MXOY, I do not know right off now, and they contain, let the total weight be what? 100 gram. Whenever they give you percentage, I'll take what? 100 gram. And metal is like say and oxygen, when they say weight is equal 50%, है ना, 50%, so this is 50%, that means what? Whatever weight you want to take, है ना. But I have shared one trick with you. Whenever they give you equal weight, what you will do? You will write down their atomic weight. So I am writing down the atomic weight of metal as X and that of what? This as 16. Yes or no? Now this has to be cross multiplied. It must be M16 and OX. Yes or no beta? Yes or no beta? Now the molecular formula of this oxide, first oxide, is given as what? MO2. If this has to be MO2, I believe that X should be double of this thing. If this is 1, this should be double, and this is only possible when what? M is 16 and O is what? 32. Yes or no? This X should be what? 32. X should be 32. Only then this will become what? MO2. Yes or no? On simplifying that, it will get MO2. But only when this is M16 and this is what? 32. That means X value is what? X value is 32. Okay. Wait. समझ में नहीं आ रहा है? I'll explain that again. Wait. देखो, मैं कह रहा हूं, remove that. इसको बिठा दो. M. Now see, the formula is what? MO2 given. To have this MO2, 2 should be here and 1 should be here. The formula of the first oxide is what? MO2 na. That means 1 should be here and 2 should be here. I have to cross multiply that. What is these things? They were the simplified atomic weight. I know that atomic weight of oxygen is 16 and if I wanted 2, this should be what? 32. That means what? If atomic weight of oxygen is 16, atomic weight of M should be 32. So now it is clear that atomic weight of metal is equal to 32. Can I use this atomic weight in the second oxide? I'll use that. Again, I'm using MXOY. I do not know how much is the formula, what is the formula, but the total weight I'll take what? 100. Whenever percent is given, blindly go with 100. And out here they say in the second oxide that the weight of the metal is given as what? 40%, that is 40 gram. Remaining will be what? 60 gram of oxygen. Is that clear? Weight is the least important thing. So I'll go with number of moles. So what I'll do, weight of the metal divided by the atomic weight of the metal, 32, which I have calculated here. So 40 by 32 and 60 by 16, which I know that stuff. Now I'll divide both of them by the smallest one. Which one is the smallest one? I believe 40 by 32 is the smaller than 60 by 16. This is 1 point something. This is almost like say 4. 16 for the 64. So this one is smaller one. So I'll divide by the smallest one. I'll divide 40 by 32 divided by 40 by 32. So this will cancel up and this will be 60 by 16 and 40 by 32. Is that clear or not? This will be cancelling up and 16, 2, 20 and 23. So this will be 1 and that will be 3. That means what? We have got metal, this is what? Oxygen. So metal will be 1 and oxygen will be 3. So the empirical formula will be what? What will be the empirical formula? Bachcho, batao. It will be MO3. Yes or no? So the trick we have used is that whenever they give you 50% metal, 50% oxygen, please write down this way. I have shared that thing previously. To get MO2 as a formula, 1 should be here and 2 should be here. And what are these? I told you, these are the atomic weight simplified. Ratio of the atomic weight simplified. If I know that this is 16, then this should be what? Double. In order to get 2, so this should be 32. हाँ कि ना? चलो आ जाओ. एक क्वेश्चन और करते हैं. अच्छा, over here in the same question, but I'm changing something. If the molecular formula of the first oxide is MO, rather than MO2, it is MO. Then what is the formula of the second oxide? So चलो try करते हैं. Let's try that. Again, I'm having MXOY. Total weight I'll assume what? 100, है ना? 100 gram. But since I know that this formula is what? M and O. The ratio is what? 1:1. I'll cross multiply, है ना? Then I'll get MO. The empirical formula is what? MO, na beta? Now, what is this 1 and 1? There are simplified atomic weights. If this is 1 and 16, oxygen is 16, this should also be 16. This should also be 16, hai na? That means atomic weight of metal should be equal to what? 16. So once you have calculated atomic weight 16, we can use that in the second oxide. So it is MXOY. Okay, total weight I'll put as 100 gram, and metal I'll take as 40%. So weight of metal will be 40 gram and that of oxygen will be 60 gram. Okay, now since I need number of moles, weight is the most useless thing in the world of physical chemistry. So I'll put 40 upon 16 and 60 upon 16. Now this is a smaller one, so divide. This will come 1. Divide both of them by 40 by 16. I'll come 1, 60 by 16 and 40 by 16. 16 cancels, 22 and 23. This is 1 is to 3 by 2. Can I simplify that? Can I multiply both of them by 2? It will become 2 and this will become 3. That means what? Metal will be 2 and oxygen will be what? 3. So empirical formula or the molecular formula will be like say M2O3. Yes or no? So this is how you are going to proceed to calculate these category of questions. चलो एक दो question और करते हैं. Let's try a few more questions, and these questions will be like say percentage based. So there are few questions, a very important one. So let's see. They're saying that caffeine whose molecular weight is 194, it contains 28.9% nitrogen, by weight. They're saying find number of nitrogen atoms nitrogen atoms in one molecule of caffeine. In one molecule of caffeine. तो कैसे करोगे इसको? The molecular weight of caffeine is 194 and it contains 28.9% nitrogen by weight. They're saying find the number of nitrogen atoms in one molecule of caffeine. One molecule. They're asking you about one molecule. So can I say in the microworld? Microworld means molecule. So the molecular weight, can I take molecular weight in the microworld as what? 194 AMU? Yes or no? I'll take it as 194 AMU. Okay. Okay. Now tell me one thing. They say nitrogen is 28.9% by weight of 194. So can I find out weight of nitrogen in one molecule of caffeine? बोलो बच्चों कितना आएगा? In one molecule caffeine will be what? बोलो 194 into 28.9 divided by 100. This is how we do percentage, है ना? So I mean this seems little bit more calculative. So can I do some approximations? Physical chemistry है, maths थोड़ी ना है ना? Can I make it 200, the nearest possible thing which I can understand? And since I have increased it, I'll reduce it a little bit. It will be 28 और ये हो जाएगा 100, है ना? Toss that. This will be approximately 56. 56 what? AMU. 56 AMU. So the weight of nitrogen is how much? 56 AMU. Now I know one thing. I know that 14 AMU weight, if I take, it contains one nitrogen atom. So if 56 AMU will contain how much of nitrogen atoms? 56 divided by 14. कितना आएगा? It will be 4. 14 4 the 56 है ना? 4 nitrogen atoms. 4 nitrogen atoms. That means in one caffeine molecule, I have got 4 nitrogen atoms. Is that clear or not? Okay. चलो आ जाओ बढ़ते आगे. Let's do one more question. And it says that there is a big molecule called say insulin. Insulin contains, they're saying that it contains 3.4% sulfur by weight. They're saying find minimum molecular weight of insulin. अब इंसुलिन का फॉर्मूला मुझे नहीं पता है, अब ना ही स्ट्रक्चर पता है. Now to find out the molecular weight of insulin, you need not know the formula and the structure of insulin. फिजिकल केमिस्ट्री यार, ये ऑर्गेनिक इनऑर्गेनिक थोड़ी ना कि यहाँ पे आपको स्ट्रक्चर पता होना चाहिए, जरूरत नहीं है. यहाँ पे they will be asking you simply the ways and means to find out the molecular weight. ठीक है, इधर देखो आप लोग. तो total weight of the insulin will be what? 100%. Out of that 100% weight, 3.4% is sulfur. 3.4% is sulfur, है ना? अब देखो जरा. What I'm saying, find minimum molecular weight of insulin. Minimum. If I want to find out minimum molecular weight of insulin, it should contain minimum 1 sulfur atom. Yes or no? It should contain minimum 1 sulfur atom. So 3.4 out of 100 gram, 3.4% means 3.4 gram. Sorry, my mistake. 3.4% is sulfur, and sulfur is how much? 32. 1 sulfur will have a weight of what? 32. At least 1 sulfur should be there, na? Then 100%. If 3.4% has a weight of 32, 100%, that is what? Insulin. 100% will have a how much weight? 32 into 100 divided by 3.4. You solve it, you will get approximately 941. So 941 is the minimum molecular weight of insulin. Are you getting it? I'll explain it again. They're saying find minimum molecular weight of insulin. They say 3.4% of sulfur is there by weight. This total is how much? 100%. Out of that, sulfur is how much? 3.4%. Now to find out minimum molecular weight, I should have at least 1 sulfur. At least 1 sulfur. Yes or no? So this 3.4%. is what? One sulfur atom, and one sulfur atom is how much? 32. Then 100% will be how much? 100% will be how much? 32 into 100 divided by 3.4. You will get approximately 941. Yes or no? चलो एक क्वेश्चन तो करते हैं, लास्ट क्वेश्चन है ना. They're saying hemoglobin is a big molecule. It contains 0.33% iron by weight. Iron by weight. Okay. Okay. They are also saying that the molecular weight of hemoglobin is given as 68,000. 68,000. They are saying number of iron atoms in one molecule of hemoglobin. चलो करते हैं, आ जाओ. Number of iron atoms in one molecule of hemoglobin. देखो 0.33% is what? Iron by weight. And if I take this entire one molecule whose weight is 68,000, then weight of iron in one molecule will be how much? 68,000 into 0.33 divided by what? 100. I mean, you solve it, you will get approximately 224 AMU. I am taking this weight as what? AMU. I am going in the microscopic world. So this will be 224 AMU. Now, this is a total weight of iron. Total weight of iron in one molecule of hemoglobin. I know that 56 AMU, if I take, it will contain what? One iron atom. But 224 AMU will have how much? How many number of iron atoms? 224 divided by 56 will be 4. So it will have 4 iron atoms. सेम मेथड, सबका सेम मेथड है बच्चों, है ना. एक बार समझ में आ गया, आपको बाकी चीजें भी समझ में आ जाएंगी बच्चों, ठीक है ना. आप इसको रिवाइज करो, अच्छे से प्रैक्टिस करो. इन द नेक्स्ट लेक्चर we'll do a very important thing, and that will be like combustion of hydrocarbons, and based on that we'll try to find out the empirical formula and the molecular formula of the hydrocarbons. We'll try to do some more question based on percentage also. But before that, you should be revising these things, है ना. We'll be using some fundamentals of these questions in the next coming questions. Okay, boys? चलो, take care. Wish you all the best. Bye bye. God bless you all. Bye. Bye bye.